So talking about logarithms, first thing you need to understand is a logarithm is just a function. We've already talked about tons and tons of different functions in this class. For example, if I put this up here, you don't need to write this down, but just look, f of x equals x squared. That's one of the types of functions we've talked about. Which is what? Close. It's related to this. What type of function is that? Starts with a Q. Come on, you guys. Quadratic. Quadratic x squared is a quadratic equation. We talk a lot. We spent like 3 months talking about quadratics, it seems like. We just barely got done in the last unit talking about a function that looks like this. It would be something like x minus 1 over x plus 4. Those are called rational. Rational means fraction. We've talked about those functions, right? We've talked about, what would you call these type of functions?
Absolute value.
Absolute value. Absolute value. We've talked, what would you call this one? Square. In particular, that's a square, but overall, the overarching type of function, that's radical. Okay? We've talked a lot about functions. This logarithms is just another type of function that has different characteristics, different properties, but every single one of these has something in common. If you plug one number into the function, what do you get? X. How many answers do you get? If you plug one number in, you get one number out. That's the definition of a function. Each input gives one output. Each input gives one output. Logarithm is a function. You can plug a number into a logarithm, and what do you get out of that? One other number. A function is something that takes a number, changes it, and produces a different number. Like all of these are functions. Okay? One reason I think students get confused with logarithms in particular, it's not that they're more difficult, but for some reason it was never given a fancy symbol like this right here, the square root symbol or the absolute value symbol. Okay? You guys, on calculators, when you're typing these in, like to computer systems and early calculators, they didn't have these fancy symbols, so they would have to use abbreviations like square root was SQRT, and then you would type the number in like that. Or absolute value was ABS, and then you would type in the number like that. So it's kind of how a logarithm is. Instead of giving a symbol, you just use the word. So if I were to write a logarithmic function, it would be f of x equals log, and then you place a number inside it. So that's what your log on the calculator is for. It was never given a special symbol. You just write out the word log that stands for logarithm. Okay?
Make it look like a log.
If you want it. But the point is, if you plug a number into it, you get a different number out of it, right? And we're going to learn how to evaluate these today. But the first thing you have to understand is a logarithm is a function, just like all of those other functions. So, get back to where you do have to start writing now. What is a logarithm? First of all, what should we write there? What is a logarithm? What did we just spend the last 5 minutes talking about? It's a function. It's just a different type of function. That's what Algebra 2 is. It's the study of different types of functions. We've done trigonometric functions, radical functions, rational functions, all sorts of them. Now, let me get back to this blank screen over here. Some functions have a lot in common, or they have something related to each other. Like I'm going to erase all but these two right here. What do these two functions have to do with each other? They look completely different. They're inverses. You guys hear that?
Inverses, yeah.
These functions are inverses. Every function has another type of function that gets rid of it. For example, this one. F of x equals 3x. Then another type of function that would get rid of 3x would be x over 3. Those are inverses. Multiplying is the opposite of division. So here's the next thing I want you to write down. Every function has an inverse. We know this. We talked about this. Every function has an inverse. The inverse is what undoes the original function. So if we have x squared as a function, what would undo the little square part?
Square root.
So many functions, we already know the inverse. Logarithm is still a bit new.
Logarithm and campfire's inverse. Units in front of the log.
For example, y equals x squared. The inverse is y equals the square root of x. So just take a minute, list a couple of those inverse functions that we already talked about.
X squared or square root of x. 2x or x divided by 2, those are all inverses.
Would this one be 2 square root?
That's what we need to talk about. This is what we've been talking about recently, exponential functions. That was 10.1, a little bit of 10.2. That was also a new function. We hadn't really talked about exponentials before. So y equals 2 to the x. Let's see how good your memories work. Why is this called exponential?
The exponent function.
It's not just because it has an exponent, because this also has an exponent, but this is not exponential.
It's in the x is the exponent.
The variable is the exponent. That's why this is exponential. The variable is the exponent.
So is it x root
To try to be the inverse of that, what you're trying to figure out? That's what I was just going to ask. The inverse is what can help us solve for x. For example, with this equation here, if I wanted to solve for x, I'd have to cancel the exponent, right? Roots cancel exponents. Did you guys all hear that? Roots cancel exponents. But here, are we trying to cancel the exponent? We're trying to cancel the base, aren't we? Because if this base weren't here, then wouldn't we just have x, and that's what we're solving for? So my question is, what cancels bases? And it's not roots. Roots cancel exponents. We need to cancel a base. Why do you think we're talking about logarithms right after we talk about exponentials? They're the inverse.
Oh, wait, log is the inverse?
Log is the inverse of exponentials. If I wanted to cancel a base, what cancels a base? A logarithm. Okay. So write this down. This is an exponential function. To solve, we must cancel the base. Logarithms are the inverse
Of exponential functions. Logarithms cancel bases. Logarithms cancel bases. That's what you need to remember about what function the logarithm performs.
A logarithm cancels a base. Why would we want to cancel a base? Well, if the exponent is a variable, we would want to cancel the base to solve for that variable.
I kind of ran out of room, so I'm going to write this off to the side, but I want you to write this underneath so it just keeps going down on your notes.
Here's how you represent a logarithmic expression. A log has a base, and it's written very small, as a subscript.
Log the y.
You would read that out loud, log base b of y. That's how you read that out loud. Log base b of y. Y is the expression inside the logarithm, kind of like what would be underneath the square root or inside an absolute value.
Is log the base script?
Y is not a superscript. Y is the term inside the logarithm or inside the function. Just like a regular number. The b is a super or a subscript, so it's written really small underneath the logarithm. reason that logarithms have different bases is for the same reason that we have different types of roots. We don't just use square roots for everything. We have to use a square root or a fourth root or a fifth root depending on the exponent. Well, it's the same thing. We have to use different bases of logarithms depending on the base of the exponential we're trying to cancel. So you can have a logarithm of any base. It just depends on the particular base you want to get rid of. That's the logarithm base you choose to use.
So, let me go back here for a second. Y equals b to the power of x. So we know this is an exponential equation. Because the variable is the exponent. What we're going to practice doing is
Rewriting this into a different form.
everybody stop for just a second. Let me show you kind of an example of something else we've done previously that has a little bit to do with this. Do you remember these problems when I said the fourth root of x to the third? Didn't we learn how to rewrite that in a different form?
Yeah.
X times X.
That's kind of the process we learned. But
X to the power of 3/4.
remember, this was x to the power of 3/4. These two things mean the exact same thing. They're just written differently. This is radical form. That's rational exponent form. We're going to do something similar now with this first objective. I'm going to give you an expression. You rewrite it in a different form, but it's going to mean the exact same thing. One form is called exponential. The other form is called logarithmic. But they're the exact same thing. They just look different. So this is an equation in exponential form. To write in logarithmic form, you use a logarithm on both sides. Here's what I mean. So I'm going to write the expression again. Y equals b to the x.
Now, it says to use a logarithm on both sides, but I didn't say specifically what logarithm, because it always depends on the base of exponential. What kind of a base do we have here? B. So that's the base of our logarithm. Every logarithm has to have a base.
So what I want you to do is write log base b, and this b to the x is going to be the term inside the logarithm. But you guys need to remember, this is an equation. If you do something to one side of an equation, you have to do it to the other side. So on this side, you have to do a log base b, and then y is inside the logarithm.
Wait, is that B?
That's a log base b. Why did I choose to use a log base b? Because b is the base of the exponential. Log base 2. Yeah? Now, what does a logarithm do?
On the inverse of exponential function.
It's the inverse of exponential functions, which means it cancels what? A logarithm cancels bases. So we have a base right here, don't we? It only cancels bases, though, if the bases are the same.
Just like a square root can only cancel x squared, right? Only if they have the same base. So here, that log base b cancels this base of b. Like that.
So log base of B, y.
Exactly. Here's a question for you. I want you to think about this for a second before you answer. Before I used the logarithm, wasn't this x an exponent?
Yeah.
Is it still an exponent now?
No.
How come? There's no base in it. So it's just a normal number x, and that's the point. If we want to solve for x, it can't be an exponent. It has to be a normal number. We've got rid of the base, so now it's a normal number. We can solve for it. So
does it just stay that number?
Yeah? So x equals the log base b of y. This is exactly the same as that. They mean the exact same thing. This is just called logarithmic form. This is called exponential form. But again, they mean the exact same thing. They're just written
differently. Y equals e to the x is the same thing as x equals log base b of y.
So here's something to practice. Write in logarithmic form. Here's example 1.
This is not what we're doing, we're not solving.
We're not solving today.
So our board is just rewriting.
Most of it, not all of it.
So 5 to the x equals 15. I'm not asking for the exact, or for what x equals, just write this in the other form, the logarithmic form.
So what would you do?
Log is the 5.
We'd have to use a log base of 5, right? So I'm going to do a log base of 5 on this side, and also a log base of 5 on that side.
Can you divide that with the base? 3 or something?
No.
Make it 10.
No. These cancel, right? So x equals log base 5 of 15. And you just leave it. And you move on to the next one.
Rewriting from one form to the other is easy. Doesn't take very long.
Right, so that would have to be we're just going off calculator.
Yeah, but you can't type that into your calculator.
So we're just going that part of it.
We're just going as far as most calculators, you can't change the base of the logarithm. I'll talk about that in a second.
What about this one?
There's a log button.
There's a log button, but I'm gonna explain it.
It's different than what you guys think. Trust me, just please pay attention. I'll explain how your calculator works in a second. 4 to the negative 2 equals 1/16. Now, technically speaking, this isn't exponential because it doesn't have a variable exponent, but it's still exponential in form. So we can rewrite this in logarithmic form.
We need to cancel the base.
Log 2 base 4.
So we're going to use a log base 4. And a log base 4. So what does the expression become?
-2 equals log base 4 of 1/16.
Negative 2 equals log base 4 of 1/16.
Okay, just one last time here, answer this question. What does a logarithm do? Cancel base. So if there's a base that you need to cancel, what do you use? A logarithm. Now, listen carefully. Let's go back to something you're more familiar with. If I want to cancel an exponent of 2, like x squared, you use a square root, right? But what if it already has a square root and you want to cancel a square root? You square it, right? So listen carefully. What if, so we already know that logarithms cancel bases. But what if it's a logarithm that you want to cancel? You use exponentials and bases. Did you guys all hear that? If a logarithm cancels bases, what cancels a logarithm?
So if
Exponentials.
the question is -2 equals log 4 of 1/16, then the answer that you want us to write would be 4 -2.
That's actually what we're doing now. What if it's already in logarithmic form? We're going to go backwards now. So here's example 2. Write in exponential form. You ready? Log base 3 of 9 is equal to x.
That's in logarithmic form already. You need to write that in exponential form. What cancels a logarithm? A base. And not just any random base. In particular here, what base do you think we're going to have to use? Base of 3. Now watch carefully how I write this because it does make a difference. A lot of students are going to want to do this. Okay, let's just put a 3 right here. Is that a base?
Yeah. No, out to the right.
Not to the right. What does it mean to be a base? It has to have an exponent. That means this has to become the exponent. So the 3 has to go down here. The 3 is the base. This is the exponent. But this is an equation. If you do something on one side, you have to do it on the other side. So I've got to use 3 as the base, and that becomes the exponent. It's called exponentiating. If you have a base of 3 and the exponent is a log base 3, what do you think happens here? They cancel.
3 to the x equals 9.
Yep. 3 to the x equals 9. These two mean the exact same thing. They're written differently. So if you want to cancel a logarithm, you use a base. If you want to cancel the base, you use a logarithm.
That's the main point of this lesson is what's the relationship between exponentials and logarithms. The main point is they're inverses of each other. So real quick, try this one, part B. Log base 64 of 8 equals
1/2. Now you write that
how would you rewrite this in exponential form?
64 just to 1/2 equals 8.
Yep. If I want to cancel this logarithm, you use that as a base. So I'm going to use a base of 64.
Which, do you ever want to solve it if it's like that?
No, just leave it. Base of 64 cancels a log base 64, so your answer is 8 equals 64. Now you want to check that it's a true statement. Is that is that true? Does 64 to the 1/2 equal 8?
Yeah.
Yeah. So the 1/2 power just means square root of 64 is 8. What if it's not true?
You mixed something up somewhere. Now you guys don't need to write this because I think you wrote it last time. Didn't we talk about this last time?
Yes.
Okay, but there's something you need to write here. E is most often used as a base. Most often used as a base. That means E is always going to have an exponent. Oh, most always.
And usually the exponent is a variable. So if this happens quite often and it has an exponent, then aren't you going to have to cancel E a lot of the time?
Yeah.
I'm just going to have to use a log base E. It's called the natural logarithm, and you use this a lot. This is one of the most often used of all logarithms, log base E.
You can do that on your calculator.
This one you can. This one you can. Your calculator can only do a couple of logarithms. This is one of them. Log base E. Now, so write this down. Log base E equals the natural logarithm. It's called natural logarithm because E is the natural number.
You will never, ever, ever see it written this way, though. Ever. It's never written that way. It's written this way. LN.
Should be. Check your calculators. Look for an LN button. It should be right around the logarithm button.
It's right underneath it.
On the graphing calculators, it's right underneath. Some students misunderstand and think the natural logarithm is a completely different type of logarithm. All a natural logarithm is a logarithm with what base? Base of E. It's no different than any other logarithm which has a different base of E. So your calculator will do natural logarithm. Okay? The graphing one, and if you rotate your sideways, it probably has an LN button here. The reason it's LN is logarithm is Latin. And like Spanish and French, the adjective comes after the noun. Yep. Yep.
So some of the problems on your homework are going to involve natural logarithm, like this one here. Rewrite this expression. Natural log of 15 equals y.
Natural log of 15 equals y. It'd be so much easier to write if your phone wasn't in your hand.
But
It'd be so much easier to write things down.
Would it be,
E to the y equals, you guys, what cancels logarithms? A base. Well, what base are we going to have to use here? A base of e. But it has to be on both sides. You can't just use a base on one side. So use a base of e right here, and use a base of e right here. A base of e cancels a natural log.
So the expression then becomes 15 equals e to the y. Keep in mind, we're not solving for the variable yet. That's next time's lesson.
All we're doing is rewriting from one form to the other. Because what you guys are going to figure out is that's how you actually solve for the variable. If it's in one form, you write it in the other. Right? Here's what I mean by that. If this was the equation that I asked you to solve, by the way, I'm going to ask you to solve this on, I think, next time's lesson. How would you solve for y?
oh, yeah.
Well, cancel the base.
Oh,
We have to use a logarithm, right? Well, isn't that what this is?
yeah.
Y equals the natural log of 15.
So are we always going to solve
a
it?
natural log.
So you set it into a calculator
So we're always going to solve it from that.
by rewriting it in the other form. If it's exponential to begin with, to solve it, you write it in logarithmic form. Or if it's logarithmic to begin with, you write it in the other way to solve it. That's how you solve these types of equations. That's why we're practicing this. So I'm not asking you to solve yet. You're just going back and forth from one form to the other. We clear? The other type of logarithm
That's kind of special is called the common logarithm. I don't know why they call it, I mean, I know why they call it the common logarithm, but it's actually not as common as the natural log. The natural log is
way more frequent than this one. But it's called the common logarithm. Our number system, almost every nation's number system is base 10 number system. That's why we have decimals, decimes 10. So since we solve problems involving bases of 10, quite often you run across a log base 10. Not as often as a log base e, but still it happens.
I have a question.
Yeah.
Why is it called base 10? It's like the log and exponent.
log base 10 means you would use this to solve something that has a base of 10 exponential.
Oh, yeah.
So you guys will never ever see it written this way either. Log base 10, you never see it written that way. It's always written this way.
Just straight log. So
With
that's
no
log-
base.
This is log base 10 right here.
That's what I was getting at on a calculator. You see how it says log?
Yeah.
That's only log base 10. That's it. It's not a log base 2, it's not a log base 5, nor can you change it either. So most calculators are restricted to two logarithms. Which one are they? Natural log and the common log. That's it. Now, some of these newer, like the 84 plus silver edition,
If you know where to find it, you can do other bases. So if you're lucky enough to have one of those, let me show you.
Yeah, you have 84 plus.
Well, the yellow one,
Yeah.
it might still have, so just, it's worth checking. Hit the map button, scroll up. Do you see how it says log and then a capital base on my screen? If yours has that feature, then
Nope.
it will allow you to type in a
logarithmic expression with different bases like this. So if you have an 84 plus, I can update your operating system to allow you to do this. But now you can type in a log base 2 and then whatever you want. So some calculators can do different base logs, but most will only do common logarithm and a natural logarithm.
How do you update your operating system?
It's pretty easy. Let's take a second. So anyway,
Holy moly. Whew, we only have 9 minutes, people.
oh,
Here's objective 2.
There's just 2 objectives. This is the last objective. We're almost done. Hang in. The bell will ring in 9 minutes. You can check your phone and play your stupid games in 9 minutes. But not right now. Okay.
Play it on your calculator? That's cool. I'll try to do that.
So, here are some properties of logarithms, most of which we've already talked about, but I just want you to write them down so you can find them easily. These are the 4 basic properties of logarithms.
Write those down real quick.
Just with this? Whoa. It's just a log base 10.
We didn't do any examples with it because we got to move on to this last objective here.
1. Log.
Now, I erased what they equal because I want us to come up with these. So just very quickly jot those down, leave a space afterwards so we can write down.
What is that? This number 2 is that log base B.
Log base B of B. Yeah. Number 3 is log base B of 1. And number 4 is B as a base, and then the exponent is log base B of x. Now we've already talked about this one a ton, this property 1. So some of you, I'm keeping my fingers crossed that you can tell me what this equals. Just equals x. Why is that? Because a log base B cancels a base of B, right? So that one should be becoming more obvious. Maybe it's not obvious now, but the bases cancel. Only if the bases match. That's the important thing. If this were to look up here at the screen, you guys, if this were a 2 right here, and that were a 3 right here, this property doesn't apply. It only applies if the bases match. Now, this one's easier than you think. What's the log base B of B itself?
They cancel, so it's 1.
They do cancel.
0, it's either 0 or 1.
It's either 0 or 1, that's true, but which one is it?
I think it's usually a 1. It's 0.
Let me say this.
Oh, they cancel. 0.
If the base is canceled, the exponent is still there, though.
But you divide it by itself, so it's 1.
That's how you flex it.
But it cancels
B is the same as B to the first power, isn't it? So if the base is canceled, the exponent still has to be left over. So this does equal 1. This one's pretty tricky. I'll be really impressed if anybody can come up with this one. Let me give you a hint, though. Put an equal sign. Now, I don't want you to write this because you're going to have to erase it anyway, but I'm going to put a question mark here. Because it does obviously equal something. Now, look at the pattern here, you guys. And this is just a quick way to check if you've done these correctly. If you start with this as a base and raise it to that power, you should end up with what's inside the exponential. Isn't b to the x equal to b to the x? And right here, isn't b to the first power equal to b? So what I'm getting at is, what kind of a number can go here such that if you take b to that number, it's going to equal 1? Let me say that again. Actually, one of the 3 or 4 that said something, one of you did say the right answer. So what number can be placed here such that when you take b and raise it to that number, it equals 1? And it doesn't matter what b can be anything. That's the thing you have to keep in mind.
Well, it has 0.
Power of 0 is 1.
Yeah, it could be 0.
It is 0. Sam, say that again that you just said at the very end. Anything to the power of 0 equals 1. That's why it doesn't matter what the base is. The base could be a 6, could be an e, it could be a 10. A b to the 0 power equals 1. That's why anytime you take the logarithm of 1, it has to equal 0. Now this one, it's actually just kind of like number 4 in reverse. A logarithm cancels a base, right? Well, what does a base cancel then? A logarithm. So what's left over from this expression?
x. There you go. So here's how we're going to use these properties. Actually, don't even write this one down because it's too easy, but just so you get an idea. We're getting into evaluating. Evaluating means something like this. If I asked you to evaluate the square root of 9, what would you say? 3, right? That's evaluating. If I ask you to evaluate the log base 2 of 2, what would you tell me? It's 1, right? Isn't it that property right here? The log base b of b is equal to 1. So that's what it means to evaluate. You're going to have some different expressions. You've got to tell me what they equal. So here's example 4. Actually, I think it's example 3. But anyway. Is example 4? Okay. Evaluate the log base 2 of 8.
But this doesn't apply. Is it not what it means?
It doesn't look like any of those apply, does it?
Nope. No, does not.
Or is it number 1?
It is actually property number 1.
Oh, it is.
No, the bases have to match.
Do you just change B into whatever?
You guys agree with that statement?
I do.
8 is nothing more than 2 to the 3rd power.
So it's log equals 3.
These cancel, so what's left over?
3.
So what's the answer to the original problem? This equals 3. Log base 2 of 8 is equal to 3 because you can change 8 into 2 to the 3rd power. Now, what I was just showing you on my pad, most of yours probably doesn't do this, but I can type in a log base 2 of 8, and what do you think my calculator is going to tell me? 3. It should equal 3. That's how you evaluate logarithms. You have to get matching bases. So let's try another one.
We're just about done. Quick, quick, quick. Log base 5 of 25. Don't yell it out.
Let everybody have a chance to think about it for a second. Log base 5 of 25.
So it's 5 to the 2, 25.
What'd you get, Matt?
2.
The answer's 2. The answer's 2.
Which one do you?
For part B, the answer's 2. Here's why. Hold on, just one second. Stay put. This 25 can change into 5 squared.
Yes. Number 5.
The 5's cancel, so the 2 is left over, so this equals 2. That makes sense, Rory?
We need all volleyball players to go to the lecture room at this time. All volleyball players to go to the lecture room at this time.